Well, happy Tuesday evening to everyone. Here we are, a ham radio class, an amateur radio upgrade class. I'm your instructor tonight, Gary, Whiskey 4 Echo Echo Yankee, and I am very proud to report that we are on the last chapter in our book tonight, Chapter 11, from the Extra Class License Manual from the ARRL, the 13th edition, Chapter 11, Safety. And safety is really paramount for all of us because you can't enjoy the hobby unless you stay healthy and stay in the game. So that's what we're going to talk about tonight in the first half of our class. Then we're going to take a 5-minute intermission, and we'll come back and then take a 50-question sample practice test to see how we do. You'll grade your own paper. So if you're watching us on YouTube, thank you very much. We've got 21 folks currently watching us. Have a piece of paper and a pen or a pencil ready after the intermission. And you can take the practice test along with us as well. So let's go ahead and get started. This is the last chapter, as I said. And what I want to convince you of tonight is that ham radio is an adventure. And when we think of adventure, I don't know about you, but I think mountain climbing and this sort of a thing. But I say that for an adventure, success is based on your own efforts. And so if you're putting a ham radio station together, you're accumulating the equipment, you're interconnecting it all, you're putting up antennas, that's your own effort. So your success is based on what you put into it, but then success is not guaranteed, and that's where luck and propagation, in our case, come in. Work and preparation, yeah, and it takes an investment in time and money, okay. All of those things go into mountain climbing or cycling or what have you. Finally, there's an element, unfortunately, of danger in an adventure, and in amateur radio, we have to face this as well. And industry has a whole group of folks that are doing nothing but working on this and managing risk, trying to minimize the chance of having an accident or a problem happen. And we have lots of hazards in ham radio. Number one we would think about is electric shock, falls from height, whether it be up on a roof or up on the tower. Radio frequency exposure, that's another. Chemical contamination from materials that we use. And hazardous materials. Well, like the old cartoon said, boy, what a relaxing hobby. So we've been accused, hey Gary, you teach the test. Yes, we do. And so tonight what we're going to be doing is talking about safety in the context of Chapter 11 and the test questions will be asked about safety. And those 3 sections in the book are climbing safety, RF exposure, and grounding and bonding. And unfortunately, the first one, climbing safety, might have been prompted by the fact that we've had, over the past couple of years, a number of senior ham radio operators who have fallen and died from tower accidents. Come back to me just for a second, Bruce, if you would. When I worked for the Voice of America, I had a real group of technicians working for me in the transmitter plant, and had lots of other folks working in other areas. We'll talk about that in a second. But I came to find out that I had to worry about the senior technicians, the people that had been working at the station for the longest period of time, because unfortunately they'd gotten away with maybe some bad habits. I didn't have to worry so much about the new guys. They were, cautious around electrical circuits and things like that. So that was my situation. That I worried about the old guys. So don't fall into bad habits, and we can all do that. So keep healthy and keep still. So let's go ahead and 11.1, climbing safety. And as I mentioned, at the VOA, at one of our overseas transmitting stations, which we call relay stations, well, this is the org chart. And so we had a manager and a deputy manager sometimes. And then we had three groups: the transmitter plant, which was involved in broadcast operations. We had administration, which took care of the human resources and payroll and all of the other stuff. And then we had our facilities section, which took care of our buildings and grounds. And a subsection of that was our rigging staff. And every station had their own independent rigging staff. These are the people that climbed the towers. And towers like these, now this was at the Radio Free Europe station in Playa de Pals, Spain. These towers are no longer upright, they're on the ground. But these are the kind of things that the riggers had to work on and to service. And so you can imagine the hazards that were involved in some of that. Cell phones. Did you realize that working on cell phone towers is the deadliest job in the United States? And there's statistics here, and here's my reference here. You know, you can be injured by falling objects, structural collapses, equipment failures, all sorts of different kinds of hazards. And we had various safety rules for VOA for antenna maintenance. The control room always had to be informed about maintenance on an antenna, for example. That antenna would be locked out at our antenna switch matrix so that you couldn't accidentally energize it with radio frequency energy. Electrical power was switched off and locked out at the antenna, because sometimes you'd have tower lighting and things like that. Grounding clamps were applied to the antenna feed point, so should all else fail, at least you'd give a high VSWR to the transmitter if somebody tried to put RF on that line. The two-man rule always applied. No less than two people could be working on an antenna. Personal protective equipment for ground personnel was always required. For those who were climbing, you had harnesses and lanyards that were up to date, rated for the weight of the climber, and always remained connected to the tower. And even some of the antennas at VOA had a ratcheting track at climbing ladders that you could just clip into and just slide up. But if you started to fall, it would lock and prevent you from falling. So, okay, we're not going to go that far in ham radio, but you really need to obtain training. And one of the best ways you can do that is to volunteer to help experienced climbers who may be working on projects in your area. So if you hear about a ham who's putting up a tower or whatnot, and you've got the time, go ahead and volunteer, because you'll learn some things about safe practices. If you're going to be on the ground, the minimum personal protective equipment should be a hard hat, safety glasses, safety sunglasses. You think about this: if you're working out in the day, you're going to be looking up a lot at the tower, and if the sun is right there, well, you want sunglasses, and of course gloves. Two-man rule: don't climb by yourself. Make sure that someone's there, that if nothing else, they can call 911. If you're the climber, you need an up-to-date safety harness rated for your weight, that doesn't restrict your movement, and at least 2 lanyards, plus a shock-absorbing lanyard that you can put overhead, and a climber's helmet. And what we're talking about for harnesses are things like this. Mastrant is one of the suppliers. There are others. But notice that it's got a shelf life. They're good, in this case, for 8 years. And after that, the manufacturer can't guarantee the strength of the stitching or the material, so you always have to have something that's up to date. A lanyard, something like this, where you can clip on to a tower if you're going to be climbing on a tower. And a lanyard is always connected to the thickest element. So the lanyard is attached to the tower rather than to the cross brace. And you want to make sure that one of these lanyards is always connected on the tower if you're climbing, so that, God forbid, if you slip or something and come off the tower, you've got something to restrain you. No free climbing, please. And as I mentioned, the lanyard's attached to the leg, the thickest element, not a cross brace. And once in position, it's recommended that you attach a shock-absorbing lanyard over your head to the tower. That way, this shock-absorbing element will, if you should fall, hopefully cushion that somewhat. And as I mentioned, ground crew, personal protective equipment. This is one thing that I heard on commercial tower sites even before I joined VOA, was the crew up there yelling down, "Oh, headache coming down." That meant they dropped something. And you don't want to be underneath it. So if you'd like to learn more about this, Valerie Hatzfeld has a nice short summary video here at this URL talking about tower climbing safety. And then Don Dazzo, I believe is his name, I'm sorry if I butchered his name. He's in the area here, I think in North Carolina or South Carolina, but he's an experienced tower climber, and he's got a great presentation here. K4ZA is his call sign. And then finally, and I wish they'd put these in a playlist. Tim Duffy, if you're listening, go to your website, to your YouTube channel. DX Engineering has a nice 5 video offering on tower safety. And you can find it on YouTube just by typing in the search engine there on YouTube, DX Engineering Tower Climbing. And it'll bring you to this first video, but it's the first of 5. Really good series, really informative. So this is kind of new this year, not so many questions before on tower climbing, but let's see how we do. So what is meant by 100% tie-off regarding tower safety?
Bravo.
I heard a bravo. That is correct. At least one lanyard is attached to the tower at all times. You're tied off to the tower 100% of the time. And to what should lanyards be attached while climbing?
Delta.
Yeah, the tower legs, the thickest elements of the tower. And where should a shock-absorbing lanyard be attached to a tower when working above ground?
Alpha.
Yeah, you want it above your head so that the distance is lessened so you don't have such a shock. So those were our safety questions from the first section. Very good, guys. So RF exposure, this is something that we talk about in the technician class, in the general class, and now here in the extra class. And it goes back to May 3rd of 2021 when new FCC rules related to human exposure to radio frequency energy were considered. And an interesting fact about this date, handhelds sold before this date, so handhelds sold before May 3, 2021, are exempt from RF exposure rules. Okay, so if you've got an old ICOM 2AT, these were the classic radio that I used in the late 1980s, well, okay, you don't have to pay attention to this, but the rules are that they affect every radio amateur, anyone who has a transmitter. There was a 2-year grace period for a while where we didn't have to pay so much attention to it, but now it's required for everyone. And the RF exposure requirements are used to improve human safety. We want to keep people safe and healthy. So as of May 3rd, 2023, that's 2 years after the 2021 date, all transmitters operated in the United States are expected to abide by FCC exposure rules. You can implement positive access controls to prevent access by unauthorized persons. So fencing around vertical antennas is encouraged. Signage is encouraged, just to let people know that it's an area of possible RF exposure. And every station must be assessed before it is used. So just keep that in mind. Now, the assessment results do not have to be filed with the FCC, In fact, they don't even have to be written, although I would suggest that you do have a written record of this. They're supposed to be kept in the station's permanent records. You do have permanent records, right? And if you're considering installing a new antenna or higher power or a transmitter, well, run a preliminary analysis first and see if it's going to cause a problem. And radio frequency energy is sometimes called radiation, but it's not the same as nuclear radiation. That is ionizing radiation, which can cause chromosomal damage and other effects. But RF radiation is known as non-ionizing radiation, and it causes heating of body tissue. So, and the sign on the left is not the sign you want. The sign on the right is the one you want, which you can buy on Amazon, by the way, RF radiation hazard signs. So you're responsible to maintain a safe RF environment by operating within published limits. And you can do this through an exposure evaluation in one of three methods. Through the methods and math that's in the FCC Office of Engineering Technology Bulletin 65, by computer modeling, which is what most folks do, or measurement using calibrated equipment, a calibrated field strength meter and calibrated antenna that works with it. So those are the three methods. And the FCC OET Bulletin 65 Supplement B, don't you love governmentese? It's specific to the amateur radio service and gives you all the details. And you can find it at the URL down below. And you may say, well, Gary, I didn't sign up for this. Well, actually, you did. When you filled out the Volunteer Exam Coordinator Form 605 to take your license exam, there's a thing right there that says you will comply with these rules. And so here's the FCC OET Bulletin 65. But most folks are not going to do the procedures that are outlined in here. Rather, and what I would suggest to do is you go to one of various sites that are available on the internet. And I checked, and these are all active. So here is an amateur radio RF exposure calculator that you can put in information about your station and your antennas and the frequencies, etc. And it will give you kind of a no-go go output to tell you if you're okay. The American Radio Relay League has their own RF exposure calculator as well, and so you can use that to put in the information about your station. And then the Lake Washington Ham Club, they've been around for a while, and they also have their own RF exposure calculator. The thing is that we need to make sure that human beings are not injured by radiation from our transmitters. And the transmitters that we're most concerned about are those operating at VHF. That's here's a chart from the FCC with power density on the vertical scale and frequency on the scale over here. And this is the VHF region. And the two lines, the dotted line and the solid line, are controlled and uncontrolled regions. Areas that have fencing and signs, that's a controlled region. Your neighbors that don't know anything about it, that's an uncontrolled region. So, and if you go into the book, you'll see this chart as well. Comes exactly from the FCC. Power density there on the left and frequency on the right. And so we're concerned about VHF. 50 megahertz and 2 meters, for example, that's where the human body is most sensitive to radio frequency energy. Maximum permissible exposure. Maximum permissible exposure, not emission. So know that MPE is maximum permissible exposure. And as I mentioned, vertical antennas, even Bruce, your new DX Commander antenna, you might want to put a fence around it that keeps people away from the antenna, because if you were transmitting and somebody put their hand on the conducting element, they could get an RF burn. So that would be a way to control space. That's what medium wave broadcasters have done for years and years and years. And putting signs up. Here's the Amazon link here for RF exposure signs. I have them up here at my house as well, because you then get a higher power density that you can work from in a controlled area. SAR, the specific absorption rate, is the rate of RF energy absorbed by the human body. And as we've mentioned, different frequencies are absorbed more readily by than others. So again, VHF, and that's why the chart has different thresholds, because the human body absorbs VHF. Oh, I just said that, from 30 to 300 megahertz. So this probably won't apply to you, but maybe to your club. If they operate a radio repeater on a mountain or share a tower. Multi-transmitter sites. Well, who is responsible? Well, everyone who is using that transmitter site is responsible, but specifically any transmitter that produces more than 5% of the maximum permissible exposure, then you've got to make sure that you're working together to reduce hazards to humans. We talk about power levels and we talk about exposure, but something we don't think about is that the higher we go up in frequency, it's easier to build higher gain antennas. So I've got a 10 element Yagi for 2 meters out over here. 10 elements on 80 meters, that would be kind of hard. But the higher we go in frequency, the easier it is to build higher gain antennas. So especially like if you go up to microwave, well, there you can have up to 30, 40, 50 dB gain. So high antenna gain equals high exposure levels. So just make sure that you're conscious of that as you're putting in microwave links or things like that. That's an area where you really have to be concerned because of the gain of the antennas. Here's our electromagnetic wave. And we saw a nice video last night at the Greer Amateur Radio Club about the Starlink system, and they talked about the E and H waves, or the electrostatic and the electromagnetic waves, and how the new Starlink dishes use that for beam forming. But keep in mind that we do have separate what they call E and H fields, the electrostatic, or E, and the electromagnetic, the H, and on this diagram it's B, but E and H fields. There are separate maximum permissible exposure limits for each, because the human body reacts differently to each of them. So know that, and also know that the E and H peaks will occur at different points physically. So that's another reason why all of these things need to be kept in mind. And ground reflectance can be an issue. It impacts E and H fields differently. So just know about all of those things related to radio frequency emission. All right, here's some questions. So when evaluating RF exposure levels from your station at a neighbor's home, what must you do?
Bravo.
So maximum permissible exposure, not emission, maximum permissible exposure, and your neighbor's house is an uncontrolled area. So ensure signals from your station are less than the uncontrolled maximum permissible exposure. Right. And over what range of frequencies are the FCC human body RF exposure limits most restrictive?
Bravo. Charlie.
Charlie, yes, VHF, 30 to 300 megahertz. And when evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations?
Carly.
Charlie. Each transmitter that produces 5% or more of its maximum permissible exposure limit in areas where the total MPE limit is exceeded. So you're all responsible, but that's the test question, 5%. So what hazard is created by operating at microwave frequencies?
Bravo.
Your transmitter may only be 1 watt or 10 watts out, but the high gain antenna that puts the beam really well formed can give you very high exposure levels in the main lobe. So that's the reason. And why are there separate electric and magnetic MPE limits at frequencies below 300 megahertz? Read carefully.
Delta.
You know my hint, but yes, the body reacts to electromagnetic radiation from both E and H fields. Ground reflections and scattering cause things to vary, and E field and H field radiation intensity peaks occur at different locations, all of those. Yes. And what does SAR measure?
Charlie.
Charlie.
It stands for specific absorption rate, and that's the rate at which RF energy is absorbed by the human body. And which of the following types of equipment are exempt from RF exposure evaluations?
Charlie. Charlie.
The old ICOM 2AT, yeah. Handheld transceivers sold before May 3rd, 2021. And when must an RF exposure evaluation be performed on an amateur station operating on 80 meters?
Alpha. Alpha. Alpha.
You always need to perform one, especially if you're going to increase power or change the location of the antenna, for example. All right. Last, grounding and bonding. And there's some great books on this subject, but we're just talking about test questions here. So there are 3 types of ground that we generally have to be aware of. There's electrical safety ground, which is a life safety issue. There's lightning protection, which protects property. And a common reference potential, what I call the RF ground, for radio frequency equipment. It keeps all the chassis of all the equipment at the same potential, but that common reference is also used in AC powering. So for AC power, you want to make sure that the ground rod system, ground rod or rods, is installed at the main breaker panel. Grounding and earthing limits over voltages from lightning and surges and faults by diverting them to the earth through grounding rods. And if you want to learn more about surge protectors, here's a nice video on YouTube with some additional information. And surge protectors are installed at the single point ground main panel. And the purpose is to make sure that all surge protection activates at the same time. If you had grounds for your AC power system that were willy-nilly all over the place, that you could get into a situation where there's differential voltages when lightning occurs. But with a single ground system, you keep things at the same level. You don't want differential surge voltages. Now, for antenna towers, grounding out there is not connected directly to the AC, but it is used for lightning protection. That's the primary purpose of an external earth out at antennas. And ground rods at the tower base are 8-foot ground rods, interconnected with very large diameter copper wire or strap with mechanical or CAD weld connections that can't be blown apart if a lightning strike occurs. One thing about grounding, however, is that it's not just about a lightning strike, but you'll see these systems, static dissipation systems. and they're not frequently used in amateur radio, but they are in commercial and cellular telephone. And the idea is these little fuzzy metal brushes that are out on the ends, the little points out on the ends actually provide a point of contact to the static charge energy that's in the atmosphere and allows the electrons to flow out at a gradual rate. That's dissipation of the charges. And you can equalize the two different levels of charge using a static dissipation system. So you can prevent lightning from hitting by actually equalizing things before things go out of hand. And that doesn't work all the time? No. But it is an area of interest. All right. Last questions. What is the primary function of an external earth connection or ground rod? Note the word external.
Bravo.
That's lightning protection. That's what we're talking about there. And where should a station AC surge protector be installed?
Charlie.
At the single point ground panel, yes indeed. And what is the purpose of a single point ground panel?
Delta.
It's to ensure that all surge protectors, lightning protectors, activate at the same time. And that, ladies and gentlemen, is the end of Chapter 11 and the end of the book. But before we take a break, let me give you some final thoughts. We've gotten a lot of folks have emailed us already that they've had their test scheduled and they went ahead and took the test and have passed. Yay! We're so proud of you. Please tell others about the class. It really helps because we want to help as many people as possible get into this wonderful hobby. And then I've had people ask me, well, Gary, is there anything else that we can do to help? Well, we don't charge for the classes, but we do have expenses for the equipment and things that go on. So if you'd like to make a donation, you can go to my website, w4eey.com, and there is a donate button there. It uses PayPal, and we would be more than happy to put the money aside, and any monies received we use for the production of future classes and other videos and what I call continuing education videos besides the licensing classes. And tell your friends, please, about the classes that we offer, because you can't beat the price. The next classes will be starting in February next month. We'll have a general class and a technician class. So for those of you who may have friends that want to get their license, please just tell them to send me an email, w4eey@arrl.net. And if they've got questions, I'll be happy to answer them and get them signed up and get some more folks enjoying this wonderful hobby of amateur radio. All right, you've earned it. 5 minutes, 5-minute intermission, and then we'll come back and we'll take a practice test together. we're back, and you may have heard me mention that Dave and Bruce and I were at a Ham Radio Club meeting last night. We go to the Greer, South Carolina club, which meets once a month on the second Monday of the month. And I want to urge you as you're finding a test session to take, if you're taking it locally, well, that's probably being put on by a club. So, find a local ham club. There's different ways you can do it. You can do a Google search. Come to my presentation if you would, Bruce, to find a club. Or if you're looking for a test session, you can use hamstudy.org/sessions. And then also the ARRL has their own Find a Club URL. And get active in a local club. It'll really continue your education as you get your extra class license. It's another advanced license to learn. And this is what hamstudy.org/sessions looks like. You can find test sessions locally, put in your zip code, or you can find online testing sessions that might be available to you. So what we're going to do tonight is hopefully get you ready to sit down, if you haven't already, and take your test. So this is practice test number 1 for the 13th edition book. There are 602 questions in the question pool. And so what I'd like you to do now is to get out a piece of paper and a pen or a pencil and number that from 1 to 50, or you can do it as we go along. And what we're going to show you are actual test questions and the actual answers that will be on your test, but it's going to be, the answers are going to be in different orders on your test that you're going to see. So don't memorize A, B, C, or D, but know what the right answer is. And hopefully we've prepared you successfully, but good luck, because we can always use some luck. For those of you who have your cameras on, if you wouldn't mind, after you've answered the question, if you'd raise your hand for me, that way I can see that you're done, and when I see most folks are done, I'll move on to the next question. When we're done with the 50 questions, we can always go back to any that we might want to review. Of course, when you take your test, you'll have as much time as you need. You'll be able to put down your memory dump sheet on the back of a scratch paper or whatever. You'll have some other resources that we can't do right here tonight. But if everybody can see the questions when I bring them up, we fixed our spotlighting problem. Thank you. And watch on YouTube. Go ahead and write down 1A or 1B or 1C or 1D, whatever the right answer is. And then you'll grade your own paper at the end. And let's see how you do. So good luck. Here is, and I won't read the question now, but I will, when we talk about the answers, I'll read the question and the right answer, unless somebody's got a question that I can clarify. You can go ahead and unmute and let me know that. So, okay, without further ado, question 1. All right, and question 2. If I go too fast, just unmute and let me know. And question number 3. And question number 4. And question number 5. question number 6. And question number 7. Question number 8. And question number 9. Again, if I'm going too fast, just tell me to slow down. And here's question 10. And question 11. And question 12. And now question 13. And question 14. And question 15. And question 16. Question 17. And question 18. And now we have question 19. And next, question 20. And question 21. here is question 22. And now, question 23. And question 24. And question 25. And here is question 26. And question 27. And question 28. Don't see anybody's got a calculator out, so go 29. And here we go, question 30. And question 31. Question 32. Here is question 33. And question 34. And question 35. And question 36. And question 37. Here is question 38. Alrighty. Question 39. And question 40. And question 41. And question 42. Question 43. And question 44. Here is question 45. And question 46. Here is question 47. And now question 48. And here is question 49. And last one, question 50. So if there's any you'd like me to go back and review, just unmute and let me know. Or if you're watching on YouTube, you could put it in the chat and I'll be able to see that. Are there any questions you'd like to go back and take a look at? Ooh, it's a tough crowd tonight. I don't see anything on YouTube either. All right, let's see how we did. You can grade your own papers. So here is answer number 1. Which of the following is a common use of a Schottky diode? D, as a VHF-UHF mixer or detector. 2, what is the maximum permitted transmitter output power when operating a model craft by telecommand? A, 1 watt. 2A. 3, what are the characteristics of an elliptical filter? That's D, extremely sharp cutoff with 1 or more notches in the stop band. 3D. 4, what must the VE team do with the application form if the examinee does not pass the exam? D, return the application document to the examinee. 4D. 5, what type of radiation pattern is created by a single turn terminated loop such as a pennant antenna? That is C, a cardioid pattern. 5C. And 6, what is the elevation angle of peak response in the antenna radiation pattern shown below? That would be C, 7.5 degrees. 6C. 7, what logical operation does an OR gate perform? A, it produces a 1 at its output if any input is 1. 7A. And 8, what is the voltage gain? What voltage gain can be expected from the circuit when R1 is 10 ohms and RF is 470 ohms? As Dave said, the big number divided by the small number, 470 divided by 10, 47A, 8A. And what type of addresses do nodes have in a mesh network? They have IP addresses, Internet Protocol addresses, 9A. And 10, which of the following is the likely result of using a Class C amplifier to amplify a single sideband phone signal? Signal distortion and excessive bandwidth, 10D. And 11, what technique shows that a square wave is made up of a sine wave and its odd harmonics? That's Fourier analysis, 11D. And 12, how does a diode envelope detector function? D, by rectification and filtering of RF signals, 12D. And 13, which is the most common input and output impedance of MMICs? A, 50 ohms, 13A. And 14, which of the following HF digital modes uses variable length character coding? That would be PSK31, 14A. And how is positive feedback supplied in a Colpitts oscillator, C for capacitor, through a capacitive divider, 15B? And which frequency band has the smallest first Fresnel zone? That's D, 5.8 gigahertz, the highest frequency there, 16D. And 17, how does the modulation index of a phase modulated emission vary with RF carrier frequency? It doesn't. D, it does not depend on the RF carrier frequency, 17D. And 18, which S parameter represents input port return loss or reflection coefficient equivalent to VSWR? That's S11, 18C. And 19, when using a transceiver that displays the carrier frequency of phone signals, which of the following displayed frequencies represents the lowest frequency at which a properly adjusted lower sideband emission will be totally within the band? D, 3 kilohertz above the lower band edge, 19D. And 20, what is the purpose of using multiple driven elements connected through phasing lines? B, to control the antenna's radiation pattern, 20B. And 21, why should effective radiated power be limited to a satellite that uses a linear transponder? You don't want to be a power hog. C, to avoid reducing the downlink power to all other users, 21C. And 22, what kind of a receiver can be used to receive and decode SSTV using the Digital Radio Mondiale protocol? That would be a single sideband receiver, 22A. And 23, what do the arcs on a Smith chart represent? They represent points with constant reactance, 23B. And 24, what frequencies are authorized to an amateur station operating under RACES rules? D, all amateur service frequencies authorized to the control operator, 24D. And 25, why does a PN junction diode not conduct when reversed biased? B, holes in p-type material and electrons in the n-type material are separated by the applied voltage, widening the depletion region, 25B. And 26, which of the following geographic descriptions approximately describes line A? That's a line roughly parallel to and south of the border between the US and Canada. I had to deal with that up in Michigan, so 26D. And 27, what is the phase relationship between current and voltage for reactive power? A, they are 90 degrees out of phase, 27A. And 28, what is the resonant frequency of an RLC circuit if R is 22 ohms, L is 50 microhenries, and C is 40 picofarads? B, 3.56 megahertz, the 80 meter band, 28B. All right, what technology is used for real-time tracking of balloons carrying amateur radio transmitters? D, APRS, 29D. And 30, what does the value of B sub Z represent? A, the north-south strength of the interplanetary magnetic field, 30A. And 31, which of the following is a significant difference between foam dielectric coaxial cable and solid dielectric coaxial cable, assuming all of the other parameters are the same? It's all of these. Foam dielectric has higher velocity factor, foam dielectric has a lower safe operating voltage, and foam dielectric has lower loss per length. 31B, all of the choices. And 32, what is chordal Hopf propagation? C, it's successive ionospheric refractions without an intermediate reflection from the ground. Much stronger that way, 32C. And 33, what is the function of a DX QSL manager? To handle the receiving and sending of confirmations for a DX station, 33C. And 34, what is the most common material used in power generating photovoltaic cells? Silicon, 34D. And 35, why is an anti-aliasing filter required in a decimator? D, it removes high-frequency signal components that would otherwise be reproduced as lower frequency components, also known as aliases, 35D. And 36, what is the purpose of a single-point ground panel? Ensure all lightning protectors activate at the same time, 36C. And 37, what is considered an acceptable maximum intermodulation distortion level for an idling PSK signal? Minus 30 dB, C, 37C. And what is the link margin in a system with a transmit power of 10 watts plus 40 dBm, a system antenna gain of 10 dBi, a cable loss of 3 dB, a path loss of 136 dB, and a receiver minimum discernible signal level of minus 103, and a required signal to noise of 6 dB? Well, the answer is plus 8 dB, 38A. And 39, what type of radiation pattern is created by two quarter wave vertical antennas spaced 1/4 wavelength apart and fed 90 degrees out of phase? That gives you a cardioid pattern with a single null, 39A. And 40, which of the following represents pure capacitive reactance of 100 ohms in rectangular notation? That would be D, 0 minus J100, 40D. And 41, what happens to SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna? SWR bandwidth is decreased, 41B. And what is the maximum permissible duration of a remotely controlled station's transmissions if its control link malfunctions? That's the watchdog timer, 3 minutes, 42B. And how is battery operating time calculated? Capacity in amp hours divided by average current, 43D. And 44, what is the purpose of the receiver IF shift control? C, to reduce interference from stations transmitting on adjacent frequencies, 44C. And 45, which of the following is an advantage of bi-CMOS logic? It has the high input impedance of CMOS and the low output impedance of bipolar transistors, 45A. And 46, which of the following parameters does a spectrum analyzer display on the vertical and horizontal axes? Signal amplitude on the vertical and frequency on the horizontal, 46A. 47, which of the following types of equipment are exempt from RF exposure evaluations? Handheld transceivers sold before May 3rd, 2021, 47B. And 48, what letter is commonly used to represent susceptance? That is B, the letter B, and also answer B, 48B. So when scheduling EME contacts, this is 49, which of these conditions will generally result in the least path loss? When the moon is closest, when the moon is at perigee, 49D, get about 2 dB more. And 50, how do ferrite and powdered iron compare for use in inductor cores? Ferrite cores generally require fewer turns to produce a given inductance value, 50C. So how did it do, folks? That's it. That's it for tonight. Hopefully you're smiling. If not, we'll come back. The last class of this series will be next week, where we'll take 2 practice tests just like this to get you ready for your actual class. Are there any comments or questions or something before we go?
Yeah, I failed. Again.
But you can do it. You'll get there. You'll get there. Hang in there.
I didn't even think of this. I told you that earlier.
I know. You're just pulling my leg. Dave, any comments?
No, I'm just really happy that we've...
Is your mic on?
no.
There,
Yes.
now my mic is on. This time it was his fault. Anyway, yeah, the first time it fell off. I'm sorry, I got distracted. Yeah, I'm just really, really thrilled about all of you that have held in there with us this far. And of course, the ones that passed, we're very proud of you as well. The rest of you will too, I'm sure. So it's been a joy working with you all.
All right, so for those who would like to torture themselves again next week for 2 practice tests, come on back. If this is your last night with us, we say very 73. Very best regards to you all, and we'll see you on the bands.
Thank you very much.
73.
Thank you.
See you next week, guys.
Okie dokie.